So let's continue this slope idea, but let's recognize that while linear functions are very nice to work with, I don't actually see that many of them on a day-to-day basis. I'm still keeping this idea of driving my car around town. Is it the case that I drive consistently 2 miles per hour, never mind that it's 2, even if it was a nice, reasonable speed? Am I driving a steady 35 miles per hour everywhere I go? No slowing down, no stopping, no speeding up. That doesn't sound very realistic. And I'd like this idea to still make sense for functions that don't have nice, smooth graphs. So I can change the formula of my f of x. Let me go ahead and make b equal to 0. Let me have m equal to 1. And let's look at the sign of x. So here is my sine of x function, and I've already broken things down significantly. My formula is trying to draw in that same triangle, the way it was before, but it doesn't look right. Let's zoom in a bit more. So my delta x is currently 1. I've moved the x coordinate over by 1, and I'm asking myself, how much does the y coordinate change? Well, this y coordinate doesn't look like it's changed at all. Maybe if I zoom in a little bit more, I can see a little bit of a vertical blue line. There it is. But that doesn't look like the right slope for my sine function. So this is like I'm in the car and I've measured the odometer twice. The odometer says I didn't actually go that far, but I know that I must have been going faster than that. It's not a perfect metaphor because on this function, my odometer has wound up and then it counts back down. So that's a little bit different than how most odometers are supposed to work. But what I want to point out is this idea of drawing in the triangle doesn't help me as much. Now, I have ways of fixing this. Part of the problem is I've gone all the way out over here to where the sine function starts to repeat itself. So if I shrink my delta x, I can move that in, and I start to get something that's more reasonable for a slope. Now, as I come in, I'm going to get different values for those different slopes here. The reason is that I don't actually have a triangle here. I've got one leg, I've got another leg, but I don't have a hypotenuse. I have this black curve here for the graph of my function. That's not a triangle. So the question is, what is the sensible number that I can call the slope here? If my x changes a little bit, what is the exchange rate that tells me how much the y changes? So it would be really great if I could zoom in until the function looks almost like a line. So at this scale, that's looking a little bit closer. Now, this is deceptive. This isn't actually a straight line. This is still part of the sine of x curve. Also, at this scale, I can't see the general shape of the sine function. So let me change my graph slightly. I have it open here in a different tab. Here I have that same sine of x function, and now I've put in what I'm going to call my magnifying lens. And the idea is I have zoomed in so much on that sine function that it looks like a straight line. So I can move my slider around. Here I see is about that trouble point I was having on my previous graph. And it looks like I can go over by 2 boxes. That'll be my delta x is 2. And I'll be going up by a little bit more than 1 box. That'll be my delta y is a little bit more than 1. So my slope there should be maybe a little bit more than a half. But I really want to emphasize here that this zoom here, this magnifying lens is something that's in my head. I can't zoom in until the sine function becomes a line, because at every scale, the sine function is not perfectly straight. So I want to be able to get something that looks like this slope, and I need rules for how to calculate